I want to start out with this. I spend time with industrial employers across the United States and certainly across the Midwest. I spend time with educators. I spend time with people at the university level, people at the technical college level, preparing that next level and generation of expertise and talent for our engineering and technical roles. And as I talk to people in manufacturing, one of the most frequent things I hear is that the ability that is most often absent in new technical manufacturing talent is this. Now, I want you to think about this. We do a great job in many of our education pathways preparing students for careers in STEM and careers in engineering. We teach them math, we teach them physics, we teach them all of this great technology. But do we always do the best job? And does every institution do the best job at teaching them how to put all of those technologies together? We're talking about this idea of integration, the idea that it's not just good enough to understand a programmable logic controller and how to program it, or an industrial robot and how to program that, or a conveyor, or a mechanical drive, or an electric relay control situation. It's not good enough to just understand all of those technologies. We have to know how those technologies work together. And as I travel around and work with industrial employers, they will tell me that that integration piece is one of the things that is most lacking in so many of the students. In fact, I've had people tell me, you know what, it's a year or two before we get them to where they're really adding value because they understand the base technology and they understand the theory, but they don't necessarily understand how to put it together. The next step after that, and we'll touch on this a little bit today, is the whole idea of design. How do we take a step back and understand an industrial application, understand what we're trying to manufacture, what we are trying to produce, what problem we are trying to solve, and then design a system in order to do that. This design part is really important as well. According to Don Norman, the famed American researcher, he said design is concerned with how things work, how and the nature of the interaction between people and technology, how they're controlled. And when done well, the results, according to Norman, are brilliant. We are going to talk today about some brilliant ideas in the area of integration. We'll talk a little bit about the importance of design. And in the process of doing that, we are going to understand how technical educators, particularly those at the community and technical college level, can prepare their students in real world ways for this world of integration. Here to chat with me on that topic is a very good friend of Webinar Wednesday, a gentleman by the name of Peter Dettmer. He has a phenomenal and fascinating background. Peter was raised in Germany, actually went through an apprenticeship program as a journeyman iron worker while still in Germany. As part of a one-year exchange program, he came to Southern Illinois all the way back in 1994. And since that time, he has served in various roles, including design engineer, production manager, process improvement engineer, project manager, sales manager, technology manager, and others in industries ranging from machining to plastic and rubber molding to automation engineering. And he has served in these roles both in the US and in the United States. In 2011, he started teaching at Madison College, where he also developed the the automated manufacturing systems technology degree. Peter holds a 2-year technical diploma in machine tooling techniques from Madison College, a bachelor's degree in information technology from Herzing, and a master's degree in adult education from UW Platteville. Peter, it is so good to have you joining us here today on Webinar Wednesday. Welcome.
Thank you, Matt. It's a pleasure to be here. Appreciate the opportunity.
And I know our audience is really excited to hear about how you're turning these amazing students into amazing integrators. I want to start with this question as we look at your program a little bit. Peter, what program are these students that we'll be seeing today in, and what do their capstone projects entail as they're going through those programs?
Yeah, great question, Matt. So the program that students can enroll in right now is called the Electromechanical Technology Program. It's a 2-year associate degree. Some of the videos and some of the references coming from the old programs that used to exist, the Automated Manufacturing Program and the Industrial Maintenance Program. Both programs always produce great students, great graduates, and these two programs are merged into the EM Technology Program as of last year. And the projects these students are doing, have done, and will be doing are for local industry. Yeah, they're doing a proof of concept of converting a manual process into an automated process.
So, in the course of that proof of concept, obviously, one of the really important parts of that is to work with local and regional industrial employers on real world applications. I know from my time serving and helping out on your advisory board, you have incredibly vibrant advisory board meetings, really, really engaged employers. Tell our audience about the employers that you partner with and how you go about building such great relationships with your industrial employers.
Yeah, it's we've been very fortunate to have a great advisory board. And when we first started out, we found industry that was looking for this next level of automation technician, and which most of them were already on some advisory boards that joined ours, or we brought them to Madison College as new advisory board members. And some of the names are the largest manufacturers in our area. Some of the standout companies like Sub-Zero and Wolf, Grande Cheese, Flambeau, Clack, Husco Automotive, Panoramic, Ceres Cycling. There's just a ton of companies we've done these projects with. And we kind of have to work with them to explain what these students are capable of. We have to, there's a survey they can fill out if they're interested in doing a project with us. And the idea is always give us a video or an example of a manual process that you want to automate. And that's where we start. And then we sometimes add some complexity or make something simpler to make sure our students can complete it in the time frame that they have.
So if you think about this, these are students in 2 year programs, and literally by the end of their second year, you're going out to an industrial employer and you are saying, give us a manual process, give us a video of something that's happening in your manufacturing operation that hasn't been automated. And then you are tasking these students with finding ways to automate these processes in ways that we're seeing in these videos and in ways that are really, really advanced and really, really impressive. Tell us a little bit, Peter, if you would, about the process that these students go through as they're working through the project of turning that manual video into an automated system.
Yeah, it's quite the extensive process. We get students after the first year. They've gone through all the basic skills, fluid power, mechanism, electricity, basic PLC, robots. So we got some great, great staff and instructors to teach them all those skills. And then they come into the integration class, and we talk about, develop a project scope. What has to be done? Identify what is the end result and how are you going to get there. So along the way, they develop some process steps that do some basic 2D layout work. They develop a timeline, a project schedule, a bill of material that includes the major components they have available. They have to do some program planning for both robots and PLCs. They do some design work, and this is where I'd like to make sure that our students are not machine design engineers. They're not going to be that in industry, but they have to understand the concept of design. Often in industry they're going to find, hey, we want to update this gripper and how we're going to mount this. So that's about the extent of design work. We do 3D printing of a lot of components and fixtures, fabrication, assembly, electrical, mechanical, pneumatic connections, wiring and field devices. They do a risk assessment, and also, primarily at the end is the troubleshooting, the debug part.
So you think about this entire process, right? We're getting students excited about the program. We are getting industrial employers excited about what you're doing in these capstone projects. These students are going through this process of some design, certainly tremendous amounts of integration, troubleshooting, solutions providing, and so on. So what is the end of this? Are the industrial employers picking up this technology and dropping it into their automated facilities? Are they using the technology or the learning in other ways? Tell us what comes after the project. Do these systems get integrated or what takes place?
Yeah, some of our employer partners wish they could, because some of these machines end up being just that good. They
Mhm.
could run in a production environment. But no, this is all equipment that the college owns. And at the end of the semester, we have a capstone showcase, and the employers can come in and it's always been very well attended. And it serves two purposes. One, students get exposed and can show off what they accomplished, and employers can come in and see what the students did, look at their resumes, and have some informal interviews. So the employers that we partner with do not get to take home the equipment, but they get to hire our graduates, which is really a win-win for everybody. And whatever our students learned, there are sometimes some unique processes, some tooling they developed. Those are all things the employers can share with integrators that might build the machines or take internal to develop an automation, a production type equipment.
And we'll talk in a little while about those opportunities for your students as they're learning, as they're leaving the program. I can also tell you from going to that capstone showcase, as you know, Peter, one of the things I miss most about COVID is being out in the field with people like your students working on amazing technology. And we're certainly looking forward to getting back into that world. But I'd be interested as you look back now on several years of these projects. Is there a specific project that you'd like to highlight or one that's particularly memorable from your years of working on capstone projects?
Yeah, you're seeing it on the screen here, the Echo fuel valve assembly. So we partnered with Echo USA. They make power outdoor equipment, and we've done 3 projects for them. This was the first one, and the students are basically created fixtures and systems to assemble a fuel line. So there's a grommet that gets 2 rubber hoses inserted that get clipped together and secured with clips, and then they get shoved through this grommet. So this was just an exceptional project, very complex. Echo ended up purchasing some dedicated valve manifolds for us. They helped us 3D print some fixtures, and the students that designed, built, assembled, wired, and programmed this, they've really taken off in the industry. And this was one of the most complex concept that we had ever done. These students put in a lot of extra time, and they owned this project. That's why, they're so engaged. That's really the big thing that we want them to, feel like it's their project, we're responsible, and we have to make these things happen.
And what incredible learning opportunities, again, as we see this advanced technology for students in a 2 year program. Really, really impressive. And I know you hear great things from other members of your faculty, from your administration, you hear great things from your students. What do your industrial employers tell you about the results of this program?
Well, they couldn't be happier. It's we get great feedback from them, and they obviously love to hire our students. And there's some employers who created positions around our degree, because this degree, is like an automation technician level, where you do more than the traditional maintenance and maybe repairing, replacing parts. We still have graduates who go into those industry. They certainly are able to do that and prefer that at some point. But the employers tell us all the time that these students come with such a broad set of knowledge and skills that they can deploy them just about anywhere. The key thing for employers is always safety and troubleshooting skills. And that's really the key that we're driving with these processes. That unless you assemble it, build it, wire it yourself, how would you ever be able to troubleshoot the system? So that's what they're really getting out of this, the troubleshooting, debugging part of electrical connections, pneumatic connections, programming, and things like that.
Well, and it's got to be almost no better compliment for a program than to have positions within your industrial employers being named after or created for the program that you have. We talk a lot, Peter, about how in many cases industry drives our programs in technical education, which is important. There's some cases where technical education has to drive employers as well and really show what's possible, what we can train and teach students how to do. Because I can tell you from firsthand experiences, when your employers see and when people in your community see the level of automation, the level of complexity in some of these capstone projects, they didn't realize that maybe you could do these types of things with students with 2 year degrees, but you prove every single year and every single semester that we can do exactly that. You talked a little bit about employment opportunities for your students and your interest, your employer's interest in hiring these students. Give us some examples or talk a little bit about when students are hired by some of your partner companies.
That's one thing that we see is that our students often get hired at the technician level, and then they improve themselves. They advance within those companies. We have a good number of students who now work in engineering roles, controls engineers, automation engineers, and that's just something that's rewarding to the students, rewarding to us, and the students know that when they first get hired, they may not be hired as an engineer, which may not be everybody's goal anyway. They want to work on the plant floor, they want to maintain equipment, but they have these skills that really set them apart. And the employers tell us that the students come in with such a good, solid knowledge of all the basic skills that you mentioned earlier, all these puzzle pieces. So the electrical, the PLC, the robots, they know all that. But then the integration part of understanding how things work together, how one thing talks to another, and that's often that allows them to be hired and paid more and be hired in higher level positions than maybe comparable students or graduates of other colleges.
And learning all these things requires not just a tremendous amount of knowledge, not just a tremendous amount of theory, but also quite a bit of hands-on interaction with this technology. And I think that's one of the many things that sets your program apart is just the huge amount of hands-on opportunities that these students get. Now, a lot of good things have come out of this COVID era. It certainly wasn't easy to go through, but I had somebody at the state system office in Wisconsin um, tell me not too long ago that Webinar Wednesday was one of the greatest things they thought came out of the COVID era. At least one of the top 10, I think, is what they said, and we certainly took that as a compliment. But in this era, in these last 12 to 15 months, that we certainly hope we're coming out of, and it looks like we might be coming out of not the same teaching environment than what you and your students were used to. So I'd be interested, Peter, if you can talk a little bit about the adjustments that you had to make to your program and particularly to these capstone projects during the era that we've lived through the last year and a half.
That certainly was a significant changes were implemented. And I say we were fortunate enough to have very good partnerships with industry already. So Rockwell Automation is one of our education partners, so is Fennec Robotics. So we have a great technology services team at the college. They made a lot of technology accessible to our students. We were able to take laptops home. So we utilized and had access to a lot of the technical training that industry has access to. So we utilize that to supplement our lectures, our demonstrations. Almost every instructor, you can see behind me these PLC trainers we have. We took those home and started creating demonstrations for students on how to do these things. And unfortunately, in 2020, in March, things were kind of cut off, and we had six projects that couldn't be finished. And we had the students continue to learn, based on what they would have done themselves. They had opportunity to put a lot of things together themselves, but hands-on, which is key to everything we do. I want to emphasize that the hands-on part, it's goes along with the planning and the documentation. And then this last fall 20 and spring 21, we had to make a lot of changes in fall since there was no access to campus. Students did a lot more planning. Of their work, and then only had 16 weeks to kind of put everything together. We were able to come on campus this spring.
So an interesting transition for your students, first of all, being completely remote in the fall semester, being back on campus here this spring, obviously with social distancing and other measures taking place to make sure that they could do so safely. And I think we agree that opportunity to be hands-on with this technology gets them so much further ahead and is so very, very important. One of the things I can tell you, Peter, is we're looking at a video of one of your students or one of your former students here on the screen right now, is one of my favorite things about your program is that these students stay engaged with you even after they've graduated and moved into the workforce. And I've met a number of them at your advisory board meetings, at the capstone projects. They come back and they want to see what those students after them are doing. They want to make sure that they're giving back to your program with their time and their talents. As these students move on into the workforce, they go through your program, they get great jobs as automation technicians, electromechanical technicians, moving on into perhaps other disciplines within manufacturing. What do they tell you about their experience once they get into the workforce, and how does that relate to what they learned during your program?
Yeah, I mean that feedback is critical to the success of our program. We take that very serious, and yeah, students reach out, through LinkedIn or just emails and say, hey, I changed jobs, and please stay in touch, and I want to be on your advisory board again. So, most recently, I had one student reach out to me and say that, he over 2 years, with COVID, he had to do some job changes. Most recently, was hired by a company that does safety audits,
Hmm.
and he was hired because he could show that he completed a risk assessment of these capstone projects, and that got him hired as a safety engineer. So now he's getting trained to be a, safety engineer for industry. And there's just those little stories pop up everywhere. We hear that all the time. That hey, this one thing, the Cognex camera, or this robot programming, or this PLC programming, or integrating things together. Yeah, those are some unique things that might have learned and exposure to, and can really use it and show these videos. That's one thing. One reason we create these videos. My colleague Rick Jacobs does a great job creating these videos, and students show them as, hey, here, this is what I did, and employers see that and they understand that the students put this together from the base table on up. Everything is put together by the students, and that really sets them apart.
Well, and I'm glad you mentioned Rick's name, Rick Jacobs. Of course, he's such a key part of your program and somebody that we know well as well. And you never miss an opportunity to bring Rick's name into a conversation, which I respect because I know you two work very closely together. And the magic that happens at Madison College is in large part due to that collaboration and that spirit of partnership that you have with Rick. So thank you for mentioning his name as we talk about these just incredible, again, opportunities for your students to not just get that hands-on opportunity at the college, take that hands-on opportunity, that knowledge, that understanding of integration to the workforce, create amazing career pathways for themselves, really talks and speaks to the importance of creative hands-on industry related opportunities for our students as they're moving their way through technical college. I want to talk about one other hands-on opportunity and give your program just a little bit of credit as well, Peter, in the process. In October of 2019, I know that your number of your students participated in the Wisconsin Industrial Manufacturing Technology Show robotics competition, a competition, by the way, that was proudly sponsored by our company, Lab Midwest, and drew nearly 30 teams from across the state of Wisconsin that competed on a robotics challenge. High school teams and technical college teams that competed again from across the state. Now, the first thing I want to mention to our audience as we see Rick Jacobs at the left of their screen, the gentleman you mentioned just a minute ago, is that in 2019, you can see from those signs. I don't know if you can read that, Peter. What is Team Robotics Competition? What does it say underneath that?
I believe it says first place.
Indeed. So your team actually won that competition, did a phenomenal job. I also want to credit you and your team for something that these three individuals in the middle did when they were so impressed with some of those high school students that participated. Um, your team actually won a Fanuc robot as a result of participating in that competition and winning it. And you felt so strongly, first of all, about the fact that you already have tremendous amounts of technology in your program. Secondly, that your team, those three gentlemen in the middle, wanted to, quote, give back to those high school students and took um, the robot that you had won and awarded it to the winning high school team, which I just think says a tremendous amount about you, about your students, about your program, and really was an incredible moment in technical education here in the state of Wisconsin. So congratulations on winning. I also have two questions for you related to this. This competition will take place again in October of this year, in the fall of 2021. In Southeast Wisconsin at the same show, the Wisconsin Industrial Manufacturing Technology Show. Number one, will you be participating again this year? And number two, what do you think your students get out of participating in an event like this?
So yeah, we got a pretty good track record with competition. So absolutely, we'll try to identify some students that are able to represent Madison College in that competition again. And as far as what they get out of it, I mean, yeah, we have Jonathan Stoll, Garrett Butler, and Skylar, who represented our program last time. And they said it was just a great team working experience. They all complement each other with their different skill sets, and they had to think pretty quick. Work together and figure out how to solve these problems, how to accomplish things. There was planning, documentation, and programming involved. So they said, it was really a good experience. They are on different capstone projects back then. So this was the first time working together, the three of them. So there's a lot to take away from these competitions: the team building, the quick thinking, the troubleshooting, the problem solving. It's really a great opportunity.
And a great endorsement for that competition. And certainly to any of our viewers, either live or on the recording, who have students who are engaged in robotics learning today in the state of Wisconsin, either at the high school level or the technical college level. Great opportunity for your students to compete, to meet industrial employers, for industrial employers to see the magic that is happening in what we call technical education here in the Midwest. So would certainly encourage all of you to participate in that robotics competition. And you can reach out to Lab Midwest for more information on that. With that, Melissa, I am going to transition over to you. And I am quite certain we've had some interesting questions roll through from our attendees. What are you hearing on your end?
Thanks, Matt. And again, to our attendees, I'll just take a moment to say, if you do have any questions that were answered through the process, go ahead and submit those, and we will make sure that we ask those to Peter. Peter, first question, are your students using real industrial equipment on these projects?
Oh, yeah, great question. Yeah, actually, our students often ask the same thing. They come in and they see these yellow robots and these conveyors, and yes, those are industrial products. This is what's being used on production floors. This is, the robots cost $30,000, $40,000, and the students don't realize, how expensive things are. And we tell them that, yeah, you're gonna work with this, and you better not break it. But unless you fail or break something once in a while, you really don't learn. So yes, those are donor conveyors, Cognex cameras. Those in the industry will recognize these names. That is actual industrial equipment that they will see and find in the industry when they start the career.
Awesome. Next question, how many hours do students have to complete these capstone projects?
Oh, yeah, great question. It's so the first two semesters, again, the basics skills, not basics, advanced skills, but the integration class starts in the third semester. The students have 8 hours per week for 16 weeks to work on in the fall semester, and then again 8 hours a week in the spring semester. And many students spend extra time outside of that working on these machines. So at minimum, they spend whatever 144 hours a semester. But most of them put a lot more time into it because they really get engaged, they really get excited, they really want to see these things through. So even with this COVID year that we had, students came in on Fridays, open labs, and worked 4, 5, 6 extra hours to get these things done.
Awesome. Next question, how many of these capstone projects do you have going on at one time?
Ooh, yeah, great. It's so I before we started, I made a list. We had 20 unique employers. We've done over 30 unique capstone projects over the last 6 years, and typically, the fewest projects we've had were 4. The most projects we've had were 8. This year we finished 6 projects. They were all for Promega, which was the first time we've done multiple projects with one company in one year. COVID forced us to kind of consolidate some of these different projects. So that's probably, at the minimum 4, always depends on the enrollment. Doing more than 8 becomes really challenging. It just takes a lot of attention and support for these students, to get these things done.
Yeah, absolutely. And I probably should have added this as well, but how many students per project?
Yep, great. So always 2 students. That's seem to be the key thing. 3 usually for somebody standing around, 1 person by themselves. Difficult to get things done, which we've had happen. We had odd numbers of class sizes, so we had a few students who work on these on their own. And just one more plug for all my colleagues out there who make this happen. I appreciate the opportunity and be the face and the name sometimes, but there are a lot of people in the background that make this happen. A lot of lab support, the office support, our part-time instructors, or the other full-time instructors. They really prepare the students to be ready for this next level.
Absolutely. Well, thank you, Peter, for your time. Matt, I will leave it to you to wrap up.
All right. Well, thank you, Melissa. What a great conversation we've had with Peter Detmer here this afternoon. Peter, program director and professor at Madison College, as you can see from the videos and the photographs, doing amazing things in that program. So, Peter, thank you so much for joining us. We are looking forward to next week as well. It's not often we get to use the words on Webinar Wednesday, world premiere, but next week we are literally having a world premiere. We have been partnering for the last 6 months, give or take, with a high school in Southeast Michigan and one of our supplier partners, Quanser, and are releasing and announcing a self-driving car lab for STEM. And it's a self-driving car lab that teaches not just autonomous vehicles, that's important, but really gets into the artificial intelligence end and machine learning end of how autonomous vehicles work. And guess what? We are teaching it as early as middle school and high school. So you will not want to miss Webinar Wednesday next week. It's going to be phenomenal. Thanks again to Peter Dettmer. For our producer, Melissa Martin, my name is Matt Kirkner. It's Wednesday afternoon, and we are here every single Wednesday for Webinar Wednesday. We will see you next week.